Hey guys, today we are going to be talking about the Pythagorean Theorem and what that means, how to use it, how to prove it. It sounds a lot more complicated than it is. One thing I just want to go ahead and preface is that you need to make sure you have something that you can calculate the square root on. I'm going to show you where you can find it on an Apple phone. If you have a calculator, most any basic calculator has a square root feature on there. So just make sure that you have something that you can use the square root, because you do need to have the square root feature when we are working on Pythagorean theorem. Okay, so just to go over the definition of the Pythagorean theorem, and I'll probably abbreviate it PT. So if you see PT, that's what it means. The Pythagorean theorem describes the relationship between the legs, which we call A and B, and the hypotenuse, which we call C, of a right triangle. So a couple of things to pull out just from that definition that are important. First of all, you have to have a right triangle in order to use the Pythagorean theorem. It does not work on an acute triangle, an obtuse triangle, a scalene triangle. Could possibly be scaling, but it has to be a right triangle, which means your triangle has to have a 90-degree angle in it. The other two things are the letters A, B, and C. A and B are called the legs of the right triangle. So this is a leg and this is a leg. And the legs of the right triangle are what make up the right angle. So the right angle, the sides of the right angle are going to be A and B, and that's called the legs. This side is called the hypotenuse. It's always going to be C. A and B can kind of be interchangeable. It doesn't matter if I call this one B and I call this one A, but this side of the triangle has to be called C, and that's called the hypotenuse. You can also think about it as the line or the part of the triangle that's across from the right angle. It doesn't actually make the right angle. And here's an important thing about the hypotenuse. The hypotenuse of a right triangle always has to be the longest side of the triangle. And we'll come back to that in just a little bit, because that's super important about how you can figure out if you're doing the right thing. You have to make sure your C side is the longest side. Okay, so there is a formula that is the Pythagorean theorem, and it is A squared plus B squared equals C squared. A squared plus B squared plus C squared. So what that means is when you square the amount for this side and add it to the square of the amount of this side, it's going to equal the square of the amount of this side. So I'm going to show you the proof of the Pythagorean theorem. If you looked at the book on YouTube that I had posted for Monday's assignment, it went through that just a little bit, but I'm just going to illustrate what that actually means. So let's say that I have a right triangle. The sides are 3, 4, 5. By the way, this side would have to be C because it's the longest side. If this is 3, that's 4, and that's 5, which means it's the hypotenuse. This one I can call A or B. I'm going to call this one A, and I'm going to call this one B. They are the legs of the triangle. So here's what this literally means. If you drew a square off of the side of this, and I know that's not a perfect square, it would have an area of 9. Because if that's 3, that would be 3, and so the area of that square would be 9. If you draw a square off of this side, if this is 4, then all the sides would be 4, and the area of that square would be 16. And then if you draw a square off of this side, and all of the sides of that square are 5, then the area of this square is going to be 25. So what the Pythagorean theorem says is this number squared, which is 9, plus this number squared, which is 16, equals that longest side squared, which is 25. And 9 plus 16 does equal 25, so that's the proof of the right triangle. So it literally involves squares off the sides of that triangle, where that side squared plus that side squared equals that side squared. Okay, So how do we use the Pythagorean Theorem in Math 8? What we're going to do with the Pythagorean Theorem is use it to solve some problems. So if you notice on my little board here, I've got 3 problems where we're solving for C, or we're solving for the hypotenuse, and I have 3 problems where we're going to be solving for the legs or solving for A or B. So here's what we're going to do. First thing that I want you to do when you're working out these problems, I want you just to write the formula down. And guys, you are going to need to work these out on a sheet of paper. You're going to need to show your work, follow through with it. It's not something you can skip steps on. Pythagorean theorem is not hard, but it is really easy to make a mistake if you're not showing your work. Okay, I'm going to call this side A, and I'm going to call this side B. Again, that doesn't really matter. I could have flipped those over and called this B and called that A. What does matter is that this side is C. It's the side that's across from the right angle, and that's the variable that we're looking for. So what I'm going to do now is fill in my variables with the numbers that they represent. So this is side A, so I'm going to substitute my variable A with 12 and put 12 right there. Side B is 16, so I'm going to substitute the 16 in the place of B, and then that is going to be C squared. I don't know what C is, so I'm going to leave that as a variable. Now we're literally going to square the numbers. When we went through our perfect squares list a few weeks ago when we were still together, we went over 12 squared and 16 squared. So if you know those, it's going to make it a little bit easier. If you don't know those, you can always do 12 times 12 and 16 times 16 and work it out that way. 12 squared is 144. 16 squared is 256. And we want to add those together to ultimately get C squared, and then that's going to help us get C. If you add 144 and 256 together, you get 400. Now, we want to solve for C squared, or for C, not C squared. So in order to get C by itself, you have to take the square root of both sides. Remember, whatever you do to one side of an equation, you do to the other side of the equation. The square root of C squared is C. That's what I want. And the square root of 400, remember that means what number times itself is 400, and that is going to be 20. And so the answer for C is 20. So just a really quick checkpoint. If this is 12 and this is 16 and that's 20, that is your longest side. So that leads me to believe I'm probably on the right track with that. Some of these are going to end up being whole numbers, and some of them you're going to have decimals. If you have a decimal for what we're doing on the assignment, just round it to the nearest 10th place. So you just need 1 decimal place for that. So we're going to go through the same process for number 2. I'm going to call this side A. I'm going to call this side B. This side has to be C because it's across from the right angle, and that's what we're solving for. So just like we did in the problem above, A squared plus B squared is C squared. My A is 7, so I'm going to substitute it in that place for A. My B is 17. I'm going to substitute it in the place of B. And I don't know what C is, so I still don't know what C squared is. 7 squared, that means 7 times 7, which is 49. 17 squared is 17 times 17, that's 289. And I'm going to add those up, and that's going to give me C squared. When you add 49 and 289, you get 338, and that is C squared. So again, your last step is always going to be to take the square root of that number. So I've got to take the square root of both sides to solve for C. When you take the square root of 338, you do get a number. You want to round it to the nearest 10th place. That would be 18.4. And again, just a quick checkpoint, that would be the longest side of those 3 sides. Okay, sometimes you don't actually have a triangle. You just have the variables A, B, and C. So you just need to drop them in the formula just like we did before. So A squared plus B squared is C squared. A is 5, so I'm going to have 5 squared. B is 9, so that's 9 squared. And here's C squared. 5 squared is 25. 9 squared is 81. And so we're going to add those up to get C squared. 25 and 81, I'm going to scoot it over here, is 106. And your last step, again, is going to be to take the square root, and C is going to be on this side, and the square root of 106 is 10.3. And just like, on the problems above, this would have to be the longest or the biggest number. So if you have a 5 and a 9, 10.3 does fit right there. So that would be the hypotenuse measurement for this. Okay, so the only difference in 1, 2, 3 on this side than this 1, 2, 3 is that now we're going to be solving for one of the legs. We're going to be solving for A or B, not the hypotenuse. So in number 1, I know this is A. That means this has to be B because I know this has to be C. A and B have to make up the right angle, and C has to be across from the right angle, so I know that has to be C. So make sure you've got everything labeled the way it should be. I don't know what A is, so I don't know what A squared is yet. I know that B is 10. I'm going to kind of skip one little step here, and if you're comfortable doing that, it's okay. I know that B is 10, so 10 squared is 100. And I know that C is 14, so 14 squared is 196. Now, here's the difference. A squared is not by itself. If you look over here at these problems, when I was solving for the C squared is over here by itself on this side of the equal sign. A squared is not by itself. So when you're solving for a leg, you're not going to add, you're going to subtract. I have to subtract 100 from both sides to get A squared by itself. Now I have A squared is going to be 96. I'm going to then take the square root of both sides just like I did before. And the square root of 96 is 9.8. So the main difference between solving for a leg than solving for a hypotenuse is you're going to subtract and then take the square root. When you're solving for the hypotenuse, we added and then took the square root. And this does fit right here because 14 has to be the longest side because it's the hypotenuse. So if I put 9.8 right there, that still keeps 14 as the longest side. So in number 2, if this is B, I know this is going to have to be A, and I know this has to be C. So if you're going to write the formula down, we have A squared plus B squared is C squared. I know that A is 17, so 17 squared is 289. I don't know what B is yet, so I don't know what B squared is going to be. C squared is 28. Most of us don't know that by heart, so if you don't know what 28 squared is, do 28 times 28, and that's going to give you 784. Okay, I'm solving for a leg. So you're not going to add here, you have to subtract to move this over here. So subtract 289 from both sides, and you're left with B squared on this side, and on the other side, 784 minus 289 is 495. Your last step is going to take the square root of both sides, and the square root of 495 to the nearest tenth is going to be 22.2. Just a quick check. 28 has to be the longest side, so this shouldn't be bigger than 28. Okay, last one is kind of like the example we had on this side where you don't actually have a triangle, you just have the variables represented. So A squared plus B squared is C squared. I don't know what A squared is. B is 35. 35 squared is 1,225, and 37 squared is 1,369. I'm solving for one of my legs, so I'm going to have to subtract. So when you subtract 1,225 from both sides, you end up with A squared is equal to 144. Take the square root of both sides, and the square root of 144 is 12. I know that it has to be shorter than this, and 12 is definitely smaller than 37. Okay, so your assignment for this is on Canvas. Make sure you read the instructions because you do not have to do the whole page. You only have to do 2 through 20 even. You are going to type your answer into the text box to the nearest tenth. I am going to be going through and hand scoring these myself. So if Canvas says you had it wrong, if it was supposed to be 13.4 and you put 13.3, I'm going to give you the points back for that. So don't panic. But just try to be careful with your rounding. And if you have questions on this assignment, come in the Zoom session. Math 2 will meet at 12, and Block 2 will meet at 12, and Block 3 we will meet at 1 o'clock. Check your email for the invitation. I will see you guys later. Thank you.